All right, we will get started, everybody. Okay, y'all can see everybody up there. So it's my pleasure to welcome everybody online and in the room to our fifth alumni panel. This is our Air and Space panel. I'm really thrilled to have Graham and Andrew here with us today, and this panel is being moderated by Professor Rutz, who some of you may have met already. He joined us after several years in industry. Working at Torrey and graduated with his PhD from UW, working with Professor John Berg. And we've been really thrilled to have him come on board, not just to bring the industry experience, but he's also been leading our industry capstone projects, as well as teaching some of our lab-based courses. So many of you, if you haven't had him yet, we'll have him in the very near future. So I'm going to hand it over to Professor Rutz. He will guide our panel today, and then just keep in mind, everybody, we'll have a reflection question posted after today's session, which is one of your required participation assignments. And for those in person, we'll do raise your hand or kind of get my attention to get questions in when we get to the open Q&A. And for those on Zoom, we'll use the chat to post your questions if you have any questions that come up during the panel, and I'll post those instructions in the chat as well. All right, Ben, handing over to you.
Great, thanks, Elizabeth. And then maybe just to introduce myself a little bit more, thank you for that introduction. But yes, I was working at Torrey for about 7 years after I had finished my PhD, where I was working on developing new materials for next generation passenger aircraft in the realm of carbon fiber. So I was doing a lot of work on surface chemistry and surface science, and then a lot of polymers work on thermosetting polymers such as epoxies, but other exotic types like bismallamides and benzoxazines. And so within the last year, I returned to the UW so that I can share some of my knowledge with the students, and it's been a really fantastic return to the UW. So with that, I'd like to introduce our speakers, Graham, Henry, and Andrew. So Graham, why don't you go ahead and introduce yourself?
Yeah, so I graduated UW Chemical Engineering in 2016. I live up in Skagit Valley, Mount Vernon, and I work for a company called Janicki Industries. I'm a lead project engineer here. I've been here about 5 years. We do primarily aerospace tooling for composite parts, and then the side I work on is actually flyaway aerospace parts and assemblies.
Okay, thanks. And Andrew?
Hi. So yeah, I graduated class 2019, so for my senior year, I did Pathways internship here with NASA at Kennedy Space Center, and immediately after graduation, started working here full time. So I've been here about 3 years. I currently work in the computer systems branch, so it's not chemical engineering related, but I work with the launch control system here down at Kennedy Space Center on the Artemis program for NASA's space launch system. So hopefully we'll be launching at the end of this summer, early fall.
Great, thank you. So let's go ahead and get into it. So we'll start with you, Graham. How did you decide air and space was the field you wanted to pursue with a chemical engineering degree? And how did you identify a first job in this field?
Yeah, so I grew up in Seattle. Air and space, it's kind of everywhere in manufacturing, right? Boeing, et cetera. Went to UW, went into chemical engineering. A lot of what interested me about that major was kind of the manufacturing side of things, the how do you produce things at scale and efficiently, things like that. But the aerospace still kind of interested me, and a lot of the new materials, the carbon fiber, and how do you apply those in manufacturing. So when I graduated, I started looking kind of in the manufacturing engineering type jobs in aerospace in the area, specifically kind of interested in the carbon fiber side of things. I didn't find an engineering position right away. I was trying to stay in this Western Washington area. I ended up taking a technician job at a company called Hexcel. The location up here in Skagit Valley makes honeycomb details for carbon fiber laminates for planes. So I took that. It was a technician job. I was working graveyard. Did that for about 9 months. And then I came over to Janicki as an engineering technician and started working here about 5 years ago. And then that job was more in the manufacturing engineering side of things, which is what I really wanted to get into, right? And from there, I've kind of grown into this project engineering role that I'm in now, which has more of the project management, still has all the project manufacturing engineering, quality, design. It's a very broad role. Yeah, that's kind of how I got to where I am today.
Great, thank you. And then Andrew, do you want to add your own experience? How did you decide aerospace was the field that you wanted to pursue with a chemical engineering degree?
Sure. Yeah. So yeah, towards end of March. I mean, I was applying for internships, and I ended up getting, as I said, NASA's Pathways, an offer for NASA, their Pathways office, and it wasn't, as I said, it was, in the computer systems branch. And I was also in the process of interviewing for, a more chemical engineering, like traditional type role. And I was kind of at odds if whether I wanted to take the NASA position or not. I had the offer from NASA, but not the other one guaranteed. I was going to fly out for a secondary interview for the other one. But I guess rolled the dice, went with my gut on it. And because I previously did IT work in the Marine Corps, and kind of got away from it and knew I wanted to major in chemical engineering. So but I went and did the internship, and it was discovered the role was very open-ended, and I get to interface with a lot of different engineers, and NASA has a lot of room for lateral flexibility. So but once I took did the internship during that summer, and realized that it had the opportunity to turn to a full-time role, and I knew it was what I wanted to do, and came back to UW and took a couple aerospace electives, rocket propulsion, and realized how well that chemical that class really was a turning point for me as well in that fall, because I took it in the winter, but it was kind of showed me that how diverse chemical engineering was in that background, and how I could apply the skills I learned in that to apply it in other fields. And it definitely can affirm that after working here for a couple of years, that chemical engineering is really just a foundation for problem solving, and doesn't limit you by any means. So.
Fantastic, thanks. That actually leads me into my next question very well. Maybe we'll give you an opportunity to speak a little bit more to that last point. But was there any particular experience during your undergrad time that prepared you specifically for the air and space industry? So you mentioned some of these classes that you took in AA, but you also discussed the breadth of chemical engineering. So can you speak to maybe the chemical engineering curriculum and how that might have contributed?
Yeah, I mean, as I'm sure some of you guys have and girls have experienced, it's kind of hard to know what, I mean, I really don't think you know what chemical engineering is until probably you finish the degree, unfortunately. You're learning all these fundamental, and all this theory and everything, and it's kind of hard to pinpoint what it is, and really explain it until you're done with it. But I mean, I think I don't know if there's one particular class. I mean, it all kind of built on itself. I know during senior design, I really enjoyed that, because I was able to pull on all the classes that I'd previously learned from it, and kind of have everything come synthesize and come together. I think again, taking the rocket propulsion course from the aerospace department, as I said, that one was really kind of solidified. This is what I wanted to do, and again, expand out beyond the traditional ChemE classes. But it all just comes together eventually, I guess, is what it comes down to. Yeah. I really enjoyed reactor design as well. That was probably one of my favorite classes. That was
well, rocket engines are really nothing but fancy reactors, right?
Exactly. Yep.
So Graham, I'll kick that back to you.
Yeah.
So what? Yeah, go ahead.
Yeah, I'll take it for that. I think really the part of what I do, right, in the manufacturing side of things, it's the process engineering aspect of chemical engineering, right? Is you have, like Andrew said, you have all these fundamentals, you do all the chemistry and the physics and whatnot. Ultimately, yeah, I'm never going to design a distillation column. My wife does that kind of stuff and deals with those. I don't. But the fundamentals of how you go about the problem, how you optimize something is still the same, right? And what's neat about the chemical engineering degree is especially towards that later end, right, into that senior year and towards the end, really start to emphasize some of that bigger picture problem solving, right? How do you integrate something, right, from a more traditional process engineer, like a refinery? How do you integrate different equipment together and balance and optimize? Well, for me, it's really no different. It's just different variables, it's different knobs, different constraints. It's people making product. It's batch processing by nature. So yeah, there's completely different process, but all the skills are the same, right? Everything you learn is about how to go about problem solving, how to optimize something, how to scale up a production. It's all there and in those fundamentals. And then chemical engineering also, I think, is neat in that it pulls in some of those industrial engineering skills, right? And it starts talking about some of the life cycle analysis, right, and that kind of side of things as well. So I think that's the part that transitions very well into just a general manufacturing engineering, be it aerospace or something else. But there's a lot of parallels you can always find, and sometimes it's more about the broader content you're learning, not necessarily about the specifics, because you'll learn those when you get into the specific industry you're in.
Great, thank you. Yeah, and to add to that point, that in chemical engineering, we're going to learn a lot of process engineering, and it's very similar. The skills are very similar to systems engineering, which is a very important, very specific type of engineering that is seen a lot in aerospace. And so that systems engineering and process engineering and chemical engineering really have a lot of overlapping skill sets. So I think, I have a bunch of questions I'd like to continue to ask, but Elizabeth, should we switch to student questions now? Oh, I'm muted.
Yeah, sorry, I was trying to find my mouse. No, we'll probably hold off. We'll switch around 8:55, so about 10 more minutes.
Oh, great, super. Okay, I thought I was running out of time. That's good to hear. So one of the other questions, maybe Graham, if you want to keep on going, can you tell us a little bit of what your day-to-day is like?
Yeah, so the project engineer role at Janicki is kind of unique because my day-to-day is really never the same. It depends on where I am in a project life cycle, right? My responsibilities will range from, early on in a project, more of the planning, taking customer data and generating work instructions for our technicians, things like that, transitioning into a build phase, right? And being out there, during first builds on the floor, troubleshooting, quality, interacting with, customers, status meetings, project management side of things. So my day-to-day is really almost never the same. Or if it is, it cycles, right? And it changes, which is something that I really appreciate about what I do is I get to do little bits of different things, and I can go, one day really deep into one thing, and then the next day get to see another aspect of engineering and project management.
Great. What about you, Andrew? What is your day-to-day like?
Yeah, I can kind of echo what Graham said. It's very, very flexible on, in the, at least on in the NASA side, but also the government side of the house, that you have your civil servants, which is what I am, a federal employee, but you also have, large teams of contractors, who are hired on to do a lot of, specific roles. But with NASA, at least in my role, it's very flexible. I'm an operations engineer in the firing rooms, but there's so we have different subsystems on the vehicle and on the ground side, and you think of there's different teams that work. There's a LOX team and a hydrogen team. There's avionics and electrical teams. So my subsystem is the launch control system, the computer system that we use to talk to the vehicle and receive the data from it. Within that, there's all different types of software products that there's development teams that have worked years on these things, and my role is to work with the team of contractors that I work with to really understand how that system works. So it's it's a big beast, but there's an endless amount of things for me to learn about it. So it's, I have the freedom to be able to, do deep dives into the software. I can train with other teams and, learn how their things work. And so it's very open-ended. And I think that's the best part about it is, as long as I'm out, as long as I'm learning something new or, continuing to learn, it's very dynamic. So I can't put a price on that as far as I'm concerned.
Yeah, no, continuous learning is fantastic. That actually brings me to a kind of a follow-on question. It's how much post-grad training did you partake in to get your position? Or maybe more specifically, how did your on-the-job training take your chemical engineering expertise and bring you to where you are today?
Yeah, so for me, we do like what's called an accelerating training program, which is 6 months when you graduate, and you have to do a special project, and part of that's also training with other teams to learn how the big picture works. But I really think it's learning the technical ins and outs of what you're dealing with. And I went through the certification process that our contractors go through to be able to operate in their role, but also learning a lot of systems engineering. That was another class I took when I came back during my senior year, and I realized how much a lot of their standards, it was like half systems engineering and half like product management. But all the different government standards that they had, a lot of it was based off of NASA and DoD standards, and I think that one really paid its dividends. It was a technical elective, but it really didn't seem too technical to me. There's a lot of more product management than I would have personally been interested in, I guess. But it's still it was invaluable to what I deal with now, and use day to day. But it's you really just hit the ground running, and as I said, you can learn whatever you really want to learn about, and so it's very, very flexible, at least in my particular role.
Thanks. What about you, Graham?
Yeah, for me, all on the job training, right? I graduated with a bachelor in 2016, and I get any further education. Everything's been on the job. A lot of it, it's about learning the particular process, right? Getting out there on the shop floor, learning how all the products built, getting hands on, and then from there, shadowing experienced engineers and learning from them, having them show you how to do things, and then just always be learning, right? There's always someone around you that knows something you don't, and just to take a moment to talk with them and figure out what they're doing, why they do it that way when you're doing it a different way. I guess getting into from graduation to where I am today, it's just always about that. It's always looking for those moments during the day when there's something to learn, whether it's how do you actually build a product and get your hands there and actually put it together, or more on the technical side of things, learning, seeing something, you're like, oh, I don't know how this works. And then you go home that night and you're like, man, like I have to read about this. And you start, looking and Googling and reading about it because it's just something you came across. Maybe doesn't even directly apply to what you're doing, but it just interested you. Some little, like, how do they make this little part? I don't need to know how they make it, but it just interests me as an engineer. And all those little things are always helpful.
Great, thanks. And then back to you, Andrew. You mentioned interfacing with all these different groups. You mentioned the LOX group and the hydrogen group. And I mean, of course, it takes a lot of people to put something into space, or a lot of people to build structures like Graham's doing. And can you say, how did your education in chemical engineering sort of contribute to your ability to sort of communicate and interact with those different groups? I mean, to lead the question a little bit, in chemical engineering, we learn a lot of different languages. We learn about physics, math, and chemistry. Yeah. Can you speak to that in your own experience a little bit?
Yeah. I mean, I think it really comes down to, I mean, when I first saw like the process of how the data comes into us, with my subsystem. It starts with physical quantities that they want to measure, whether that's temperatures or voltages or switches being on and off, and then you take analog signals and you have transducers that take, and then analog signals that turn to digital, and it really just came down to that process. And I remember I had just taken like my instrumentation class during my end of my junior year, and also I think that that elective really helped, but also just being able to take a step back and look at the big picture of how the process works. And I think that big picture process design is I lean on that every day, and ultimately being able to take a step back and make a decision on how things can be improved or be done differently is really what it comes down to. I mean, for me, and also chemical engineering allows me to be able to speak other groups' languages and understand what's happening. So it's having that broad background that you can apply and talk with other engineers and make informed decisions is really where chemical engineering kind of shines. It's and my boss tells me every day, when they came across my resume, he's like, well, I don't know, he's chemical engineering, and again, I didn't apply to a specific role. I just applied to their program that had 8 different engineering disciplines, obviously expecting to get the chemical one. And and he still jokes around me this day, and he's just like, yeah, we weren't sure about you, and because you're chemical, and but I think I've definitely changed his perspective on that. And when I look at interns coming in now, I always take a look at the chemical engineering education guys, because I know they can do it. You know what I mean? It's so that's
I had a similar experience when I was doing hiring. Yeah, so I definitely hear that. Graham, do you want to take a crack at that question?
No, I don't have a lot to add. I think Andrew said a lot of that very well. I could echo a lot of that, especially with his comments there towards the end about people sometimes overlook chemical engineering in the aerospace or just manufacturing in general, but it really does do well as a kind of higher level looking at things, having that background and knowledge in all these different areas that maybe a mechanical engineering degree doesn't provide, right? The chemical engineering degree really does provide a little bit more of that integration. So having all these fundamentals and how do you integrate it together? How do you optimize a system? So.
Super, thanks. And that actually does bring us to another good question, a student question. And where'd that go? So one question that we had, and I actually will take the first crack at it, but Andrew or Graham, I'd like you to add after I address this a little bit. But the question is, can you tell us a little bit more about systems engineering and how it relates to process engineering? And so systems, so something like the SLS or any rocket or any airplane or anything is a combination of an incredible number of different types of systems and subsystems. You have mechanical systems, propulsion systems, chemical, electrical, physical systems that all need to be sort of integrated. And then building that is that not only do you have the thing that you're trying to build, but you have to build the machine to build the machine. And so then you have all of this very large, very complicated manufacturing system to make this complicated thing. And so the brilliance of what systems engineering tries to do is to sort of keep track of everything and make sure everything integrates, both from a realistic and a technical standpoint, but also very much from management and a project management standpoint. And so often the biggest challenge with manufacturing isn't necessarily what you're trying to build or the technical challenges of it, but it's trying to make all the pieces work and making sure that that you have people that know what they're doing and that things are being made to tolerance and to spec. And so and in process engineering, as a chemical engineering, it's very much the same sort of ideas. You can see this plant and you have all of these different pieces, parts, of different flows and different reactors and separators, and you're trying to bring all of these things together in the most efficient sort of way. And so, that the what makes up your block flow diagram might be different, but it's very much still the same sort of concept. Do either of you guys want to add to that?
I think you encapsulated it very well. Yeah, it's I think I've been working on my master's part time. I took a spaceflight operations class, and one of the they go over systems engineering in it, and I think what the professor said, it was a quote from, I think somebody who worked at JPL, one of the NASA guys. NASA's really big, and aerospace is also. I mean, systems engineering is really what drives everything. Your entire your design, it all comes down to requirements and the formal process of verification, validation. But the quote that sticks with me is sometimes people say system engineers are jack of all trades but master of none. And I think the quote was that really, to be the best systems engineer, you want to be a jack of all trades but master of one. But you really do have to be able to speak the other languages of other engineers very well. But it's really, and again, it wasn't, if you guys have room for it, I recommend taking it from the aerospace department. It's a technical elective, and I definitely think it's a valuable class. You can squeeze it in. It'll, no matter what industry you work in, you're definitely, if you're doing design or operations or anything, it's you'll come across those principles, and it'll pay dividends for sure. Thanks.
And so to pivot a little bit, Graham, I have a good question from the audience that I'd like to ask you specifically. And I think this is something that I actually thought about when I graduated. But what is it like being a technician? Was it hard to break out of being a technician and into engineering? And were there helpful things that you learned in that time as a technician?
First of all, I think it's invaluable to have hands-on experience in the industry you're working, doing the job. I mean, to be the one that's out there producing a product, you will very quickly learn how best to communicate instructions and things like that, right? You'll see what works well, what doesn't. So there's just so many things if you're paying attention, right, to everything going on around you. Where were the inefficiencies while you were working? Why were they there? Were there better ways to do things? And then taking that experience, I think then the next thing is just you have to be looking for opportunities, right? It may be the same place you're at, or it may not be, right? In that case, it didn't quite work out at that company. So I moved over to Janicki, but always looking for those opportunities. So I went from that, it was a production technician role, into, they call it an engineering technician. So it was just kind of that natural progression, right? And just taking everything one step at a time, always trying to learn those little pieces of whatever you're doing. Don't just, show up and do the job, clock in and clock out, but actually try to learn something from it. And then try to learn, especially from the position you're trying to go to, right? So I really wanted to be in that manufacturing engineering role. So I was trying to watch, well, what do these manufacturing engineers do? What is it that I can learn, or what is it that of how they interface with the job I'm in right now that maybe if I were in their position, I would do slightly different from now my new experiences in this role.
Thanks. Yeah, no, there's always room for enthusiasm, always opportunity to move up if you're willing to put in the effort. So I love that. Maybe back to you, Graham, and then I'll ask the same question for Andrew. But let's get into the weeds for a second. So what's a specific project that you worked on that you're really excited about? Or what's a project that you're working on that excites you now? If you can share any details.
Yeah, so I won't necessarily share details about specific projects, but the product I work on, right? So really what I do is structural composites for the aerospace industry. So these are, internal structure or external structure, and all industries, right? It's, things like you think commercial, right? Planes, rockets, like Andrew's throwing into space. So that's, and also the defense side as well. And really, I think one of the ones that I've been involved in heavily right now that's interesting is we're starting to get into not just like when I started, it was okay, well, here you build this composite laminate, right? The geometry can get challenging, the size and scale that we often deal with to the tolerances is extremely challenging. But we've gotten pretty good at, detail composite parts. And now we're starting to move into actual structural assemblies and putting them together. So that's really been kind of what I've been heavily involved in right now, and it's really, really interesting. It's a whole new set of challenges, right? Now, it's not just about making one good part, but well, how does it interface to the next? It's not just I make it to my customer standard and I send it to my customer. Well, now I'm sending it to myself, and how do I put it together and then deliver these actual essentially sections of planes and rockets and et cetera, right? To customers.
Thanks. Andrew, what are you excited about? What are you working on right now that excites you?
So, as I said, we're working on our first launch here, which is unmanned. So we know we're in an operational flow right now, and I think I really enjoy that aspect of it. And also, so I mean that's in and of itself. I remember the first day I came back after graduating, we did some training with the whole launch team, where we were throwing out anomalies and being able to sit down on the headset and listen to the communication structure happen there. But I think one of the things I'm most excited about is seeing. As I said, I have the opportunity to submit, ideas for improvements and seeing those come to light. So right now, we did our what's called a wet dress rehearsal, where you load up the rocket with the propellants, and we've with being just a large system, we've had issues. We had to roll back to what's called the vehicle assembly building there and fix a lot of things. But right now, I'm looking towards the second mission, Artemis 2, and I'm seeing ideas that I've submitted in the past come to fruition, where we're starting to develop those in our software. And to me, that's really and I'm getting hands-on with the development on that. And that's what's exciting to me, is seeing those things that being able to make decisions and speak up for really the contractors that I work with that don't have the opportunity to advocate for themselves and make things better for my team of operators. That's really what I enjoy.
Yeah, that sounds really satisfying.
Yeah.
Next question. So, Andrew, you mentioned that you're working towards your master's degree. So did you get support internally to pursue that, or was that really self-motivated? And how did you decide on the timing?
Yeah. So they did have what's called a graduate fellowship program. I think it went on, and it used to be pretty open-ended, where you could go and take courses and they'd pay for it. I think they kind of cracked down on it in the last couple of years, and then it was pretty a selective program. And I think they kind of postponed it during COVID for whatever reason. I don't know if it was because of that or what, but I still had a good bit of my GI Bill left over, enough to stretch it out and get it done that way. So I kind of said, if I could have done their fellowship program, then it would have been, you can use 20 hours per week, to do your work on your education. But I kind of I still had the means to pay for it myself, and so that's kind of they were supportive of it in that aspect. I mean, they're very supportive of continuing education, and but the other thing that I want to say is I guess I was also kind of dealing with like imposter syndrome, or like I felt like I was getting away from my chemical engineering roots, and like I felt like I was maybe perhaps pigeonholing myself, working with computer systems. And it's like, right, well, if I want to shift roles, I gotta how am I going to be able to do that later on? Or I kind of was having an identity crisis, so to speak, which is no longer the case. As I said, I've developed and learned in the last couple of years that chemical engineering is very flexible, and it doesn't limit you by any means. And so I'm okay with where I'm at now, is what it comes down to. But I still enjoy, like I said, I'm definitely getting a lot out of the graduate level classes as well. to continue to expand on that formal front. But it's not needed. It's also it is what you make it, I guess.
Great, and that actually does bring us to a follow-on question: is do you think a secondary degree, a master's or a PhD, is particularly useful in air and space? And so, you sounds like you're doing great things with the bachelor's. You just said that it's maybe not necessary, but how do you feel? Is it potentially useful in what you do?
Yeah, I mean, I think so. I mean, again, everybody's different. I can't speak about getting a PhD. I think that's a very, very large commitment, and it takes a lot out of. To me, it's not right with where I'm at personally, and I got a wife and kids, and if I were to go and get a PhD, I don't know, to me, it's not for me. But I definitely think it's something that you should think about early on in your bachelor's, or I mean, and again, people go back to school after working for a couple of years and decide, hey, maybe I want to go and get a master's. It definitely doesn't hurt. Again, that's something I would encourage you to, talk with advisors while you have, and talk with your professors now that you have, to see what their experience is and get that perspective from a PhD. It's definitely beneficial. It's, getting a master's. I think that's more low risk than getting a PhD. So that's my 2 cents.
Yeah, and I think you make a great point that the timing of a master's degree is pretty flexible, which I think that students should keep in mind. Graham, do you have anything to add to that question?
Yeah, I mean, I think it just really depends on kind of where you see yourself in my type of a role, in kind of manufacturing, project management, project engineering. Master's, PhDs probably not necessary. Now, if you see yourself like you're really passionate about more of the research and development and some of that and working in that, then definitely that has a lot of value. So it kind of there's different ways you can go with it. And one thing I'd say is in the aerospace industry, if you are looking at that like further education, I'd highly recommend probably diversifying, not necessarily doing a chemical engineering master's or PhD, but going and looking at another, maybe it's the material science side of things that you want to do the research and development in, you do that, or maybe it's some sort of mechanical engineering, you kind of want to apply more of that side of things. That would kind of be my take on it.
I agree. Yeah.
That comes to the versatility of chemical engineering, is that it does set you up to get higher degrees in different sorts of fields if that's what you choose to do.
Mm-hmm.
Great. So here's another question from Elizabeth, Professor Nance, actually. So Graham, she says, Graham, I loved your perspective on thinking of each job as an opportunity for growth and learning. I meet with a lot of students who often express concern about making the wrong decisions about a first job. Can you elaborate a bit more on making a decision about taking that first job? How do you know a first job is the right first job?
In some ways, like, I don't think there's necessarily a wrong, because the worst thing is you find out it wasn't for you. And just as long as you're keeping an open mind, I don't know if you necessarily go wrong. I think to me, the balancing act is having maybe some people have more of a master plan than others, right? And do you see it as a stepping stone to get there? And do you enjoy the type of work, right, and the people there, right? When you go to somewhere, is it somewhere you can envision yourself spending 40 plus hours a week at, and that you're going to learn something while you do it, and from there, yeah, I mean, I think until you start doing something, you won't know. It's hard to learn what a job's going to be in the couple hours you research it or you talk to people. Until you start doing it day to day, that's when you learn quickly, and you start to you get exposed to that industry, and you very quickly start to see which way you want to go, and what you want to do.
What's your perspective, Andrew?
Yeah. Let's see. I mean, yeah. I was a non-traditional student. I, was in the Marine Corps for 4 years before, and I definitely had doubts about whether, when I came back to school, I started, community college down in, Vancouver, Washington, and I kind of doubted, I was competing against kids that were still in high school, and I had, a wife and two kids, and I kind of questioned, like, did I make the right decision doing that? And and then because I knew I had to get, very high grades to get accepted into UW's, ChemE program, and I definitely think that I mean, yeah, I had a difficulty, coming from like a lone wolf perspective, trying to get good grades at the community college, whereas, the way that UW, if you guys haven't found it yet, you will. The way that the program is designed is to really, the assignment, especially your first couple semesters, is, you're going to have to learn to work together and brainstorm, because that's what real industry is like. I mean, is working with other people and, troubleshooting and coming up with ideas, and you're never going to solve a problem by yourself, especially with large systems. But I mean, yeah, definitely getting. I mean, I don't think there's a wrong answer for. I mean, again, depending on how the job market is, take whatever role you can get and make the most out of it, and you can transfer those skills into other roles. Absolutely, you're not going to pigeonhole yourself by taking a role early on. There's always something to learn. Absolutely.
I think that's great advice. And one thing, so when I was at Torrey, I was doing some hiring mostly of more junior scientists. And one thing, a bit of perspective maybe for the students, is that we wouldn't approach or read a resume as a perfectly linear thing. We were interested in your total experience, and so just because maybe you had some experience in some sort of tangential fields or something, it wasn't, oh, clearly they're not, that this isn't the job for them. They have this tangential experience, but we would consider the resume and the experience as a whole, and so trying something out or doing something that didn't turn out to work out exactly the way that you wanted to really isn't the end of the world. So I want to talk back real quick a little bit to some of the coursework questions. And so Andrew, you had some really good perspective about some technical electives that you suggested, to branch out, to maybe try some technical electives in some different engineering departments, which I think is great. But Graham, I wanted to give you a chance. Were there any technical electives, or even just, I guess specifically technical electives that you would really recommend that worked well for you?
I'll start with, there's one that I probably wish I had done, and that would be Perfect. Some sort of like CAD, like drafting type course to get introduction to 3D modeling. That's something that's used a lot in the industry I work in. Not that you can't learn on the job, I did, but it would have been nice to have had some background and be able to say, yeah, I'm more or less familiar with this software. So that's something I would recommend if you're interested in any sort of career that might get involved in that, to get yourself exposed to that in some way. It may just be via a club or something like that. Otherwise, as far as curriculum, my thing is just take what you're passionate about. Find things that just genuinely interest you, and maybe outside of the engineering. You learn a lot from some of those courses that aren't directly engineering related, especially with how to communicate and all these different skills that are really important as an engineer that you won't necessarily get in a science technology course.
Yeah, thanks. I think that's really good advice. And then for those of you that are going to 375 here in just a minute, a lot of these skills, these computer skills, learning CAD or computational fluid dynamics or the basics of programming, they're just adding to your skill set, adding to your quiver of skills. And so collecting as many skills as you can in undergrad, I think is a really good approach. And so I think we're almost out of time. And so I'd like to transition to some rapid fire questions, where I'm just going to ask you guys a question. And then maybe we'll just do Graham and Andrew, because that's the order that you're on my screen. And just, real short answers, maybe just a couple of words or a sentence. Sound good?
Yep.
Great. So what is a habit that contributes to your success?
Continual learning.
Andrew?
Oh, you stole mine.
It can be twice, that's fine.
Finding out who you need, communicating with people and networking. Absolutely, networking with other teams.
Yeah, definitely. Let's switch it up so we don't steal all of Andrew's answers. Andrew, if you could go back to undergrad again, what one thing would you do different?
Tell my younger self not to be so stubborn early on and network early on with my class.
And Graham?
I think I would have found a engineering club to join.
Super. And then lastly, Graham, what's the coolest thing about your job?
I build things that fly.
And Andrew?
Being able to launch a rocket hopefully soon.
Build things that fly.
Stole mine again.
Yep.
Super. Thanks, guys. I think that's just about time. Elizabeth, do you have any closing comments?
No, just thank our panelists for joining us today. Thank you, Professor Utz, for moderating the session. We'll give you a round of applause, at least from the in-person and online crowd. You see clapping above for, yeah, we really appreciate y'all.